Now let's consider the closure property for integers. First, let us consider the addition of two integers. When we add two integers, let's say we are having an integer 3 and we are adding it to 5, both are integers, we get the result as 8. Now 8 is also an integer, so we can say the closure property holds good in case of addition for integers. What about subtraction? When we subtract two integers, let's say we are having 3 and we are having number 5, so 3 minus 5 we are going to get minus 2. Now minus 2 is an integer because integers include positive numbers as well as negative numbers. So in subtraction also we find that the closure property holds good. What about multiplication? When we multiply two numbers which are integers, let's say 5 multiplied by minus 2, the result is again integer. So we find that the closure property holds good in case of addition, subtraction and multiplication. What about division? We take an example here. Let's say 7 divided by 3. Now 7 divided by 3, we are going to get a fraction which is 7 upon 3, and we know that 7 upon 3 is not an integer, it is a rational number. So since it is a rational number, we can say that the closure property does not hold good in case of division. Next, we are going to understand the closure property for rational numbers. The four operations. The first, addition. We take rational number 2 by 3 and add it to another rational number 5 by 3. We find that the result is 7 upon 3. Now in this case, we find that when we are adding two rational numbers, the result is also a rational number. So I can say that for addition, the closure property holds good in case of rational numbers. What about subtraction? We look at another example, let's say 5 by 3, and we are subtracting 1 by 3. 5 minus 1, we are getting 4 upon 3. The denominator is same in both cases, the examples that we have taken, so we can directly add or subtract the numerators. So here also for subtraction we find that the closure property holds good. Third case, let's see multiplication. Let's multiply 5 by 3 and 1 by 2. 5 by 3 is a rational number, 1 by 2 is also a rational number. When we multiply this, we get 5 upon 6, which is again a rational number, and therefore I can say that the closure property holds good in case of multiplication. What about division? Let's say 7 upon 3 is divided by a 0. Now here there is a problem, because when I divide any number by a 0, we know that the answer is not defined or infinity. Therefore, except for this case of division by a 0, then we say that when the division is 0, it is not possible. So I can say that the closure property does not hold good in case of rational numbers, because when we are putting the value of the denominator as 0, the result is not defined.